Good day and welcome. It's great to have all of you here. I am so excited to be with our two panelists today to talk about where we are with advanced analytics and artificial intelligence and machine learning. It's a very, very complex subject, both complex to execute on, and complex to talk about. But I am thrilled to have two true pioneers in this area with us today. And we're going to talk about what's going on in general, what's going on in their organizations, and where this journey is headed. I've got Chad Konchak, who is Assistant Vice President for Clinical Analytics at North Shore University Health System in the Chicago area, and Dr. Brian Patterson, who is an Assistant Professor in Emergency Medicine and is Medical Informatics Director for Predictive Analytics at UW Health in Madison. And I am so glad to have both of you here today. And we'll plunge in, but let me just start out by making kind of a broad statement, and then my panelists can hack me to death. But my broad statement is, one of the things that we all know is that a great deal of hype got attached to the subject of AI and machine learning in healthcare a few years ago. And most people will be familiar with the Gartner hype cycle. Well, the initial roll up the mountain was very high, and then some people fell into the trough of disillusionment after things didn't work out magically. It turns out there's nothing magical in healthcare. It's all hard work. But what's great is that Chad Konchak and Dr. Patterson and their teams are doing the hard work, and they're making great advances in their organizations. So it's a good moment for us to talk about AI and machine learning, because we've gone through the first few years in which a lot of things were over-predicted, and now a kind of a sense of realism has set in, and I think that people are accepting that and realizing that where we're headed is indeed the proverbial journey of 1,000 miles. Gentlemen, I hope that that made sense and was generally something to be agreed with.
Yeah, for sure. Yeah, and I don't know, Dr. Patterson, if you want to comment first, or I'm sorry, Mark, if
either way, we're going to be totally free flowing. But why don't we start for just a moment or two at that 40,000 foot level? Maybe react to what I said just now, that there was a great deal of hype, expectations were high, perhaps very unrealistic, and perhaps there wasn't a true understanding of what AI can actually do in healthcare. Chad, why don't you begin? And then we'll go to Dr. Patterson.
Yeah, sure. And I mean, I guess I would start with, this wasn't just a couple of years ago where the hype started. And I feel like the notion that, as you said, there's going to be this magic technology that, especially in advanced analytics, let's call it, that's going to completely transform the way we, do healthcare delivery. I mean, that's been happening ever since I started here 12 years ago. And I imagine very much before that. You can probably remember all the hype around kind of big data. It almost feels like to me that it's the same foundational challenges, which is, how do we actually translate maybe the technology into like true consistent care that's right in the hands of the, clinicians. But the technology just kind of keeps changing, or rather the labels that we're applying to it of the technologies keep changing. Like I said, it was big data, or before that, it was probably predictive analytics, and then it was big data, and then ML, and now AI. And truly, I don't think a lot of the fundamental technologies changed too much, although it, it has certainly evolved. It is still those kind of core challenges of a keyword I think you said, Mark, is teams, right? It's about getting the right teams together. It's not about hiring a bunch of, PhD mathematicians and having them kind of manipulate data, and all of a sudden now we're doing AI in healthcare. It really is a complex, group of frontline clinicians, operational stakeholders, data engineers, as well as data scientists, mathematicians, that all kind of need to come together, row in the same direction to make, meaningful progress. So I don't know, Dr. Patterson, if that resonates with you.
What do you think, Dr. Patterson?
Yeah, I'd agree. I think the idea that we're at some sort of inflection point here with artificial intelligence technologies does ring true to me. And I like your setting of it in that Gartner hype cycle. I think we've been in a place for a long time where a lot of the talk has been about what it's possible to do with AI, which I think is just as exciting as it ever was. But almost more excitingly, now people are actually doing it. And of course, there was bound to be some disappointment there. I think now we're seeing people actually putting the rubber on the road and getting these models implemented, and people are finding out it's a lot harder than we thought it was. And a lot of it is this idea that a good model alone doesn't guarantee success. It's just hard to change workflows. It's hard to affect change in healthcare, no matter how good your model is or what insights it can provide. And I think that's provided some of that disillusionment. But I do think that we're headed in the right direction, and these technologies have the potential to transform care and are still going to do so. It's just about, as Chad alluded to, getting big teams in place to implement these effectively and to realize that there's a lot more to it than just having a model that's operant from a mathematical perspective.
Exactly. And if I may add, I'm about to date myself horribly here, but I grew up watching the Jetsons on TV. And one of the things about that was, of course, everybody was flying around and they were wearing jet packs, which didn't turn out to be a great idea for a number of reasons. But those kinds of entertainments gave people the idea that things would be like super automatic, right? And almost magical. And I think the thing about AI in healthcare was when people first heard it, they thought, oh, it'll be magic. Well, there's nothing that's magical. And the hard slog of analytics remains the hard slog of analytics. We're just advancing those analytics now. Tell me, both of you, what are the biggest challenges that your teams have begun, have been mastering that people should understand about doing the work? What are the key things that you've had to work through and perhaps still are working through that are particular to AI? Dr. Patterson, do you want to go first?
Sure. I think for me, like moving through this journey into getting some of these models out in the open, like a lot of people, I originally assumed that the problem was a data science problem. And it still is in some sense. Getting these algorithms to work isn't easy, and there's still work to be done on the data science side with regards to bias, generalizability of models, interoperability between sites that we shouldn't overlook. And it is the first step to getting something to work at your institution, is to get the data science solid. But I think the challenges that I found moving through these models are that it's just as hard then, once you have a model, to design a workflow around that model that's going to allow people to use it to gain insight. And then it's just as hard to get people to buy into that workflow, that even if you have a good model and a good workflow, you're not there yet. Then you need to get your providers on board with the fact that it's a good idea to interact with this thing and that it's going to help them and help their patients take better care.
Yeah, absolutely. Chad, your thoughts?
Yeah, no, I'm going to repeat a little bit of what Dr. Patterson said. I always think about the hardest parts of the whole process are the bookends, with like the actual data science work kind of being in the middle. And definitely, I mean, that's not that it's easy by any means. It's, you know, obviously you need the expertise to do it right, but kind of necessary, but not sufficient to have good data science practices. And what I mean by the bookends is certainly, you know, that last mile problem of like, if you have an amazing model with incredible predictive capability, if it's not really, you know, it's kind of the so what, right? You know, if I were to tell a bunch of people, you know, that there was a 60% probability it was going to rain tomorrow, and I was really accurate about that, you know, well, that's going to mean a lot of different things to a lot of different people, right? Some people might, you know, just brush it off. Who cares if I get wet? Other people are going to bring an umbrella, maybe not even go outside. And what we're after is true clinical standardization, right? So that so what do I do with that? And I think a lot of the deployments of these models are, I'm just gonna, you know, put up a score in front of Dr. Patterson and wish for the best. 67% probability of return to ED. Like, okay, so what? Is that good? Is that bad? Like, what's the normal amount of probability? And then the other bookend is all the data collection. You know, I think if you were like, go to an academic program of data science, you have this like nicely curated data set, and then your end goal is a good, you know, predictive power. So you're just forgetting about those. And if you think to carry on a little bit about the front part of the bookend, you know, if you think about all of the things that truly drive better health outcomes, it's really about what's happening outside the four walls of a health system, right? It's the social determinants of health, right? The environment where people live, the decisions that people are making day to day. And we don't have any of that data in most health systems, or if we do, it's at a geographic level, maybe census tract median income, or we're starting to collect that information in various ways, but like it's not being integrated to our EMR data. So they're like an AI, that's the fuel it needs to really, really perform on. And that's just not in a lot of places being well organized or being well thought through. So those are the challenges. Again, it's the bookends of the problem.
Yeah, absolutely. And so that helps me segue beautifully into something I was going to say, and I've discussed this with both of you. I've discussed it with other experts like yourselves, and it's this, and maybe it wasn't a conscious expectation, maybe it was a subconscious expectation that, as I like to put it, at some point we would all just go to Target and pick algorithms off the shelf, right? I know that's super oversimplifying it, and also Target would never have medical algorithms anyway. But the idea being that we could just that algorithms could be developed kind of out there in the abstract, up in the sky somewhere, right? And then everyone could just apply them. And I met both of you gentlemen at the HIMSS conference in Orlando this spring, and the last speaker at the Machine Learning and AI Symposium was Suchi Saria, who talked about how everyone thought that we could simply take wholesale algorithms developed around sepsis prediction and just like plug them in. And it turns out that you can't actually do that. Now, one of the things to me, and I always make very clear, I'm not an informaticist, I'm not a clinician, but it's fascinating to me, that problem, right? The idea that maybe some people thought, well, a bunch of people thought that you could create algorithms in the abstract and apply them in the concrete. And that's not really turning out to be the case. And that has caused some disenchantment, because it's like, wow, we can't do that. So that means that you are developing algorithms in teams, in specific patient care organizations, applying them to specific situations. And a lot of this has to do with how things are documented in the record, as both of you have mentioned. Dr. Patterson, can you speak to that? Particularly the fact that there were some people in the field who might have thought subconsciously, maybe even a few consciously, that we could create abstract wholesale algorithms and just apply them. And that's just simply not turning out to be the case.
Yeah, and that initial thought is certainly understandable. I think if we look in medicine, how we've worked for a long time now is this idea that if we develop some algorithm or pathway that's based on the physiology of our patients, and we develop that pathway in a representative sample of patients somewhere, and then we externally validate it at some other place, it's a pretty good bet that it's going to work in most places that look like the places that it was developed. And that's still true, I think, broadly, regardless of how the algorithm was developed, as long as you're assuming that everything about those places and the inputs to the algorithm are the same. And if we look at algorithms that were developed in years past using statistical techniques like recursive partitioning or logistic regression, oftentimes we have algorithms that have pretty simple inputs that are standardized explicitly across institutions. We look at risk scores in my area of clinical practice, where it's like, has this person had a heart attack? Does this person have diabetes? These are going to be true as much at my hospital as at Chad's. But when we get into sepsis detection and we're using AI, what we're looking for with these algorithms is often an order of complexity above, where we're looking at thumbprint signatures in the data that aren't necessarily reflected the same way. So we may be getting down from, does this patient need fluids, to how many times have fluids been ordered in the past 6 hours? And that may be documented very differently for me than it is for Chad. So if I take an algorithm and just ship it over and flip the switch, we might see much different results. And that's one of the reasons that I think almost everybody in the field suggests that to turn an algorithm on in your area of expertise or in your hospital, you're going to want to make sure that you do some local validation first, that you turn it on before you're putting it in front of your patients or actively scoring people, just to make sure that your results are going to match those that are advertised out of the box.
Right, exactly. Chad, your thoughts on that? And thank you so much. You explained that really beautifully, Dr. Patterson. I appreciate it. Chad, your thoughts?
Yeah, no, I mean, I agree. I mean, you hit the nail on the head, right? I mean, it's not just, right, there's two problems, like, is where the algorithm, where it's been developed, is that a representative population, right, that shares characteristics with, a population that you're implementing it. So I think the classic problem there is like with readmissions, like a patient population maybe in Baltimore, a highly urban, very diverse, community, the different variables that might predict a readmission might be really, really different at, say, maybe a community hospital in, like, the suburbs of the Midwest, right? And then in addition, let's assume that it is a representative sample, exactly what Dr. Patterson said, like, are you just plugging the inputs in the right way, right? And I would say, like, even if those things are right, like, let's argue and say you can go and buy an algorithm up at Target. You can plug in from your EMR vendor exactly the algorithm, but it's kind of like saying, I want to have a really successful party, right? You can't go and buy that at Target, right? You could go and buy a book on how to make a good, like, steak recipe or a good casserole, right? But you still need to go and figure out all the ingredients that are in there. Like, you need to invite people to the party. You need to make sure there's music. You need to make sure everyone's having a good time, that there's an agenda out or whatever it's going to be. So it's the same thing. Like, even if you had a perfect algorithm, to the point before, there's so much more that needs to happen to truly get to what we're after, which is improved health outcomes. That is far above and beyond just the algorithm itself.
Absolutely. Now let's talk about buy-in and participation of physicians and other clinicians, because what I've learned from both of you, as well as other experts, is that is just incredibly important, because like everything else in healthcare, again, this gets back to there's nothing magic in healthcare. It's all hard work with brilliant people, dedicated people, but there's work. There's no magic wands. One of the things I've heard from both of you and from others is you absolutely have to have clinicians involved in the creation of the algorithms with whoever you're using, data scientists or whatever category of people who are helping to build the algorithms. And as you told me, Dr. Patterson, you have to be in the right specialties too. I mean, obviously, if you're going to create an algorithm for specialty, then the specialists in that specialty need to be involved. Radiologists and pulmonologists are different people. And if you're going to do an algorithm that you're going to apply to pulmonology, you're not going to want radiologists necessarily involved, and vice versa, or at least you'll at least need the key specialty, and then maybe some others might be involved for validation of some kind. Tell us a little bit about that, Dr. Patterson, because I know that you have experienced that, and you've worked with with physicians from various specialties as you've developed algorithms with your team.
Yeah, I do think there's nothing people like less than feeling like something is externally imposed on them with these tools, especially depending on what the aim of your algorithm is. If it's, physicians, we pride ourselves on how we take care of people, and a lot of these algorithms really move into the territory that we consider our core job skill, deciding if someone has sepsis, in my case, in the emergency department. And so I think we need to be really careful to make these collaborative, to take input from users who are in the workflow, not just for technical accuracy, but for answering that question, as Chad was alluding to. Like, just having an algorithm that works doesn't help. We need to get it into a workflow at a time where it's going to help people, that we're not telling people things they already know, telling people things that they can't pull any levers to change these outcomes, even if they know that they're coming. We need to find that spot where information is actionable and is coming in. And I think having buy-in from physicians is important, is important on that level, but it works both ways. There's also often physicians come into this algorithm development or algorithm adaptation phase having a lot of preconceived notions about what artificial intelligence is and what it can do. And one thing we always talk about is managing the expectations. Often people tend to look at these algorithms in sort of a crystal ball sense. It's strange. It's how we look at artificial intelligence, how we've been told to think about it over time, where it's going to give you a yes or no answer. And then either you agree with it, in which case you think it's okay, but you probably already knew that anyway, or you disagree with it, in which case you've decided this is stupid, artificial intelligence is stupid, and you're not going to engage for the next 6 models that come down the line. We need to find ways to get physicians to see these as adjuncts to their decision-making. This algorithm tells me some piece of information more in a co-pilot sense, like, hey, I'm looking over your shoulder, I see some data that maybe you haven't put together this way. Computer thinks that maybe this patient's at a higher risk of sepsis, just consider it. Those types of messages people can absorb and make better medical decisions, where they're going to take that information in and then bring it into the whole field of everything else that they're thinking about, and hopefully make better decisions.
Yeah, exactly. Thank you so much. And Chad, you certainly have spent a lot of time, I don't know if the word is negotiating with, interacting with, negotiating sounds like Middle East peace with, conflict, but, interacting with physicians and getting their buy-in. Can you respond to what Dr. Patterson just said and how that works? Like, what is the secret sauce of, getting a certain cadre of physicians really excited and very engaged and bought into a process like this?
No, right. I mean, I'm not a clinician. Full disclaimer here, right? I'm the one that runs the analytics team, right? And I think of my team. We're in the business of building better tools, right, or helpful tools for clinicians, right? And I think part of to the earlier comment of like, there's this going to be a awakening moment where AI is now the reality, and it's I think that's the wrong way to think about it. And this is now more commonplace, but the A standing for augmented intelligence instead of artificial, right? That it's really, I think of it as a better tool to support clinicians. And how do you build a better tool? You need to first understand what the problem is that's trying to be solved for, right? A model where you have a data science team come up with a brilliant solution and then try to sell it, right, is in my mind the wrong approach versus, hey, Dr. Patterson, what are the stones in your shoes right now? Where are you struggling? Oh, okay. If you're not sure when the system is going to be really busy, that leads to maybe more boarders in the ED. So maybe we can help you with more proactive alerts when things might start to get busy, right? That translates maybe more to a better tool. And like, sorry for like the dumb analogy, but it's kind of like if you've ever like tried to like drill a hole into a wall and you use a stud finder, right, to do that. Like, it's never perfect, right? Have you ever done the thing where you're like, oh no, that's not it, and then you go over here, oh, that's not, and then finally you find it, but you start to figure out how it works, and after, it's not like you're throwing it in the garbage, right? It's not telling you like what picture to hang, right, or like exactly where to drill or what drill to use, right? It's a tool as part of a larger process that's helping you to do your job a little bit better, right? And I think that while that's maybe not a perfect analogy, like that's the way I think that we approach it. And then can we just enhance the success of that tool with better science, with better, more integration into the EMR and things like that. But at the end of the day, it is, what is the problem that's trying to be solved, and how does this tool support the individuals that are, ultimately the ones accountable for solving those problems?
Yeah, exactly. And I had attended an artificial intelligence session at RSNA, Radiological Society of North America, in December, and it was really, really interesting. So a bunch of radiologists, and one of them is with one of these large national radiology practices now, where everybody's all over the place. And she and her colleagues have developed at the time about 6 or 7 algorithms. And one of the key things she said is, first, you have to have an identified need, right? I mean, she said, we're not going to work on something that nobody really cares about, come up with some problem that isn't really a problem. Well, first of all, that's a waste of energy. But the need also drives how people interact around it, right? Because she said, as we develop these algorithms, in each case, we had people, volunteering and sitting down and discussing what was the need. What did it look like? What did we need to do? Like what kind of tool could we build? And then of course, constant refinement and then testing. But it starts with identified needs and kind of identify a consensus on what it is people want to know, right? That, I mean, it seems simple, but sometimes it's hard to get to simple. So gentlemen, both of you, why don't each of you share with us, spend about 5-ish minutes talking about some advances that you've made that you feel particularly good about, and just kind of describing them. Why don't I have you go ahead, Chad, and then Dr. Patterson, just tell us about a couple advances in your organization.
Yeah, so I'll give you two examples that kind of describe a little bit of the two bookend problems I talked about. The first is around, we built a lot of predictive models and we deployed them. And we started to run into this issue of kind of the predictive analytics equivalent of alert fatigue, right? We've heard in kind of EMRs and BPAs, the concept of alert fatigue. But like, what does a clinician do if they get their alert for, hey, high readmission risk, hey, high mortality risk, hey, high, a risk of immediate deterioration, whatever. Like, what are you supposed to do with all of that information, right? And in fact, you can imagine an example of someone who's two patients that are both at high readmission risk, but if one's at high mortality risk and the other is low mortality risk, those are actually totally different like patients. In our data, in fact, they're about 20 years in age different. And there's a problem there about not thinking about how these models create a risk profile versus thinking about them individually. So one thing we created and implemented actually a couple of years ago is something called the Clinical Analytics Prediction Engine, published on this. But it really takes this concept of how do the different models create segments within your population? And then most critically, how do we collaboratively design with not just the physicians, but also the nurses and anybody else engaged in that patient care, the primary care physicians upon discharge for readmission? What are all the different things that need to be done? So instead of, hey, high readmission risk, you're on your own, right? It's saying, look, based on all of these things the patient's at risk for, it's going to start to populate a checklist of interventions, right? And then those interventions are also going to get spread across the care team, right? It could be that the MA at the primary care physician's office is the one that needs to set up that follow-up appointment, whereas maybe the pharmacist needs to be the one upon, within a reasonable amount of discharge, working with the patient to make sure they understand their medications that they've been prescribed, right? It's not all following on the physician, right? High deterioration risk, yeah, that physician needs to immediately evaluate them for ICU placement. So it's really this engine that then takes these models and then triages, right, the different interventions. So that's, I think, the first thing that's been really transformational, but it's a lot of hard work to organize and document all those interventions and how they map to the different thresholds and the different segments that get created. And we're still in a constant flux of adjusting that and measuring the effectiveness of that. But that's been very transformational, because then someone doesn't have to interpret what 67% means. It's just, here are the things that now I need to do because this patient needs a little bit more attention. Or, by the way, hey, you can ignore these things because they're at low risk for so much. We can actually take work away from you. Let's not forget that version of this thing. That then I think has started to create a better ecosystem. And then on the front end, in terms of data collection, we've implemented an operational natural language processing engine where we're actually extracting social determinants of health from all of the clinical notes. So we're able to now identify, for instance, our EMR indicates that like 95% of our patients are primary English speakers, which is by no means the case. And we're finding that a great number of our patient population from this NLP extraction, that's incorrect. So why is that important? Well, we send HCAP surveys out to our patient populations primarily in English, and big surprise that we're well underrepresented by minority groups and Spanish-speaking individuals, right? Because of this problem. So we can actually start to use this NLP AI to better impact more vulnerable populations and then also understand what are some of the barriers that they're having to these outcomes, transportation issues, and other things that are getting to what's happening outside of the four walls of our health system. So hopefully that was in your 5-minute deadline there, but
well,
things I wanted to highlight.
It was absolutely perfect. I said 5-ish and it was 5-ish. So Dr. Patterson, why don't you share with us?
Well, this is perfect. Maybe I'll be a little shorter because it sounds like Chad and I definitely agree on what the important things are. These are the cutting edge innovations we should be working on now, because mine are pretty similar. So so similarly to Chad's group, we're implementing a mix of models. And for us, I think we're excited about doing some models which are in, which we're working with third parties to bring in with vendors, but then also some that we're building in collaboration with our academic partners on the university side. One thing that I'm always happy to be doing is to be working on the academic side, not just with folks from data science, but also we're increasingly collaborating with our engineers to design workflows, and with experts that we have in dissemination and implementation to start to work on what is the process of moving a model from one hospital to the other beyond the data science. Like, what are the package of interventions that can get people to maybe need a little bit less work, or maybe a little bit more prescribed work, to get clinicians to take on a model at one of our new hospitals that's already functioning at an existing hospital. Our models come in pretty diverse areas. We're using discrete electronic health record data to predict events like sepsis and deterioration. But I'm also excited about using models, instead of trying to make decisions we're already making better, to allow us to do more for our patients. So doing more preventive care during an ED visit, for instance. We have a model that predicts patients who are at high risk for falling down after an ED visit, and then facilitates a referral to our falls clinic. Much like Chad's group, we're also very proud of our work in the incorporating text data in real time. I do think that this is an area that a lot of people are going with. More than 80% of the electronic health record is locked up in text, and doing NLP, not just doing NLP, but doing it in real time as notes are entered into the system, is what I think is going to give these models a new level of performance. And we're just starting to roll out our first models that use NLP-derived features in real time on the hospital side.
Oh, that's wonderful. I have to say, Dr. Patterson, I mean, the issue, the free text issue feels like, I don't know, a 1,000-year challenge or something, just something huge, right? And so that's very exciting. Thank you both so much. So what have been the biggest learnings in these advances that you've made, kind of broad strategic learnings? Why don't I start with you, Dr. Patterson?
So I think in terms of broad strategy or advice, I think when we talk about these teams to bring the models out, I would say you're sort of as strong as your weakest point. It's easy to put too much effort into any one area, and you need all these competencies, so it's tough. You can't neglect any, but you need to think about how, as you have the team, you're going to need that data science proficiency in your institution to make sure that, as we talked about, that a model that works somewhere else actually works at your place, and that you could build the sort of technical piping to get it to realize the workflows that you're designing, which is often very difficult. Like, we often think if we have a model that works and we know how we want to bring it into the workflow, that it just happens. But sometimes some of the hardest work is getting the right data in the right space, even when we think it should be possible. But I think not neglecting any one of these pieces of designing the workflow, and then really managing the implementation well to make sure that providers are aware of these models, are interacting appropriately, and then managing the governance once models are implemented. How do we deal with an ecosystem of models that are going to be, as we all roll out more and more of these, are the structures we have in place to monitor 10 hospital-wide going to serve us when we have 50 or 100 hospital-wide? How can we do this without taking up too much time, and making models more similarly and leveraging institutional experience?
Wonderful. Thank you. And Chad, biggest learnings from what you just shared?
Yeah, and maybe I'm going to say the same thing, but kind of just spending too much time on the predictive model itself. I mean, you could spend a lifetime on, thinking about more data, getting a better, predictive capability AUC. When in reality, just like Dr. Patterson said, like, you're as strong as your weakest link. Like, if you're not solving for everything, then you've got a really good maybe academic paper about a statistical paper at best. I guess it's kind of like, if you're building a car, right, and all you're doing is trying to build like the most amazing engine, right? Like, there's a lot of other stuff you haven't figured out yet, right? And I would even argue, right, like, you could maybe start with a really simple, like, rules-based algorithm and solve for everything, and then iterate with that algorithm to improve it with a better predictive model that, where those other more complicated things, I would argue, are getting kind of sorted out and integrated. So yeah, it's too much emphasis on the predictive modeling aspect.
It's interesting that you say that, Chad, because you're coming from the analytics side and not the clinical side. You could spend endless hours doing this, right? To me, one of the things that really strikes me in what both of you shared here, which is so terrific, is there is such a great need for really good multidisciplinary collaboration in all this, right? It can't just be the data scientists or data analysts, and obviously it can't just be the clinicians, because they would not be able to develop the models by themselves. And what strikes me is that for this to work really well, you have to have the right culture to begin with. Because if you don't have a really good culture of collaboration, and if you don't support this development in a practical way, give people the time, build the time into their work lives, it's difficult to do this, right? And I know a lot of hospital systems are out there whose leaders would like to create more space for this, for the development of AI and machine learning algorithms. And they haven't quite figured out how to do that because everyone is pressed for time. What are the few things they can do to create more space for this? Apart from, of course, hiring really smart data people like Chad and creating teams to work with the clinicians. But what can leaders do to kind of jumpstart all of this work in their organizations? There are a lot of organizations that have done nothing so far. Dr. Patterson, do you want to say?
Sure. I think I really like Chad's idea here, which is start on something simple. I think doing the second one is not anywhere close to half as hard as doing the first one. If you have one model of some type that you're bringing out, all the work is in getting the infrastructure, the know-how to do the testing, and then the second one already feels like you're good at it. And so I think the key thing is just to optimize that first implementation. Find some area where there's a burning clinical need, where other institutions have already done this very well, that you can go out and look and see how they've done it, where you have clinical champions already on the ground and you've already won some of that provider battle. Certainly between all the different specialties and all the different areas where these models could be used, I would suspect that almost any organization can find some place where there's somebody like asking to be given a model. And you can find a model it doesn't have to necessarily be technically the state of the art. Just finding something that can be done within the bounds of your current technical limitations. And once you get one success out there, you're already rolling the ball down the hill to get more and more done. I think one of the problems with these models is that many times a bad implementation is way worse than having done nothing because it poisons the next one down the road. So starting on something that you're going to get a low-hanging fruit and winning is the way that I'd recommend going.
That's a great suggestion. Thank you. Chad, do you want to add anything to that? Or?
Yeah, I mean, just to spin, totally agree. The answer to your question is finding the right use case, right? Because a bad use case, you're destined to fail, right? But there's probably a lot of low-hanging fruit-esque use cases out there that are probably more apt for modeling. The kind of nuance I would say is it depends on who you're asking the question to, right? Is that a question for the CEO who wants to start to develop this as a competency? And if that's the case, I would say, okay, what are the main key operational priority areas, the biggest stones in your shoes, right? And then where are, for those issues, is there a population segmentation or kind of a risk, a risk stratification, a dimension to where that could help solve for that problem, right? Because sometimes look, we've got staffing issues, right? That maybe predictive analytics isn't the easiest thing to solve for that, right? Or we have a lot of falls. Well, are people just not following the current workflows that are in place? There might be other issues there, or if you're asking an analytics leader, it's, hey, go out and find the Brian Pattersons of the world, find your buddy, right? That can really help you team up and do these things, right? Or if you're the Brian Patterson asking him that question, who's the analyst or the data geek, that you can partner with? So I think it's who you're asking that question to, but I think it all ends up boiling down to what is the right use case?
Wonderful, thank you. Last question for both of you. What do the next few years look like, and what will this space that you and your teams are advancing in so beautifully, what will this space look like? Let's say, I'll pick this number out of the air. 3 years from now, what will things look like? Dr. Patterson, you want to go first?
So I think we'll certainly see continued increase in interest and investment in this area. What I'm really excited about is I think we're going to start to see more and more outcomes from centers that have implemented these models that are able to share real concrete results on patients. That as it goes from, this is like a cool thing you can do to be on the leading edge and it's going to help your patients, to I think we're going to roll very quickly into, this is something that clearly helps patients and it's becoming standard of care. There's going to be a lot of pressure to implement these things. And one of the questions is how quickly it will become true standard of care to get these implemented.
Absolutely, yeah, that's a great comment. Chad, anything you'd like?
Yeah, I mean, on top of that, for sure, I would say the technology is going to get better, right? Like the NLP off-the-shelf products are just going to get better versus having to kind of build everything from scratch yourself. And it's just going to be, higher end technologies are going to be more accessible to people, and especially how they connect back into electronic medical record. Like, think about 10 years from now, 10 years ago, there was no predictive model that you could get. And now that's pretty much, plug and play, so to speak, with your EMR. So the technology is going to get better. I think the healthcare environment itself, we've been saying this for a long time, but I think the move to risk models and population health and the need to model and include what's happening in the social determinants of health to really solve for higher value care and population health, I think is also going to drive, to Dr. Patterson's point, the need for investment in this area, because if we can't identify who our most likely kind of segments of our population are to have high medical spend, have bad experiences and all that stuff, like the organizations that can do that well are the ones that are going to succeed.
Yeah, absolutely. I'm so glad you brought that up. I agree with you completely that as healthcare moves forward, as patient care organizations move more fully forward into value-based contracting, it will become even more important because money will be at risk, and that will help drive things. And I also think, based on everything both of you shared with me and others have shared, I think clinicians, especially physicians, are just going to become more accustomed to this. It won't seem so weird and woo-woo. I'm sure the first time in any particular patient care organization that someone comes to them, whether it's a physician leader like Dr. Patterson or an analytics leader like you, Chad, and says, well, we're going to do, we're going to build an algorithm. People are like, whoa, like which doctor, but once it's like anything, once you start really doing it, then it becomes normalized that people do it. And I think what you said, Dr. Patterson, is absolutely true. There will be more templates and more case studies over time. In some ways, this space reminds me of population health management, because 15 years ago, everyone's like, whoa, how do we do this? What is this? Now everyone knows what population health management is. And there are a lot of great case studies and templates. So it's not so mysterious anymore. I think this whole area will become far less mysterious over time, and that will help. So unfortunately, speaking of time, we are out of time. This time has gone by very fast because I've had two great guests with terrific thoughts to share. So Dr. Brian Patterson of UW Health and Chad Konchak of North Shore University Health System, I want to thank you both so much. This has been a truly great discussion, and we're deeply honored that you joined us today.
My pleasure.
Thank you.
Thank you very much. So this concludes the session. Thank you to everyone in our audience for viewing this, and have a great rest of your day.